Hello friends, welcome to Risingpearl.com. Today we are going to take a look at question number 28 that appeared in 2016 CBSE Class-X Math exam, and how do we solve that question. That's what we're going to do in this webisode, in this video. So the question 28 goes like this. In the figure below we have been given a diagram. The vertices of triangle ABC, so we have a triangle ABC, and the vertices, the coordinates are given. So for A it's 4, 6, B is 1, 5, C 7, 2. So A, B and C vertices are given. A line segment DE is drawn to intersect the sides AB and AC at D and E respectively. So DE is a line that intersects AB at point D and the line AC at point E. The line DE is drawn in such a way that AD by AB, that is this AD divided by the entire length AB, is equal to AE by AC, the small length AE divided by the entire length AC, and that ratio is equal to 1 by 3, right? That is what is given. Calculate the area of the triangle ADE. We have to find out the area of the triangle ADE, which is this triangle ADE, smaller triangle, and compare it to the area of the bigger triangle ABC. So the entire triangle ABC. So how are we going to solve this? So friends, first of all, there are actually quite a few different ways to go ahead and solve this question. So the first way would be that we know that these two triangles ADE, let's write it here, triangle ADE and triangle ABC. If you look at these two triangles, what is given is AD by AB is equal to AE by AC, right? And this ratio is 1:3. So if we take a look at the line AD, so or think about any line like this, if this is A and if this is B, and if we know the coordinates of these 2 points, and here we have point D, now the ratio in which AD is to AB is 1:3, right? It means that if AD, let's do it this way, AD by AB is 1 by 3, or we can say if it is x, this would be 3x, right? So if we say this part is x and the entire part is 3x, that means this is 2x. Or in other words, point D divides the line AB in the ratio 1:2. So if this cancels out, this is 1, this is 2, right? So if we know the coordinates of A and coordinates of B, applying section formula, we can find out the coordinates for the point D. Because we know the coordinates of A, we know the coordinates of B, applying section formula, and we know that D divides the line segment AB in 1:2 ratio, we can find out the coordinates of D. Similarly, we will be able to find out coordinates of E, right? So what we will have is that we will have all the coordinates known. A, B, C are given, we can find out D and E. Then question becomes, if we have the 3 coordinates, can we find the area of a triangle? So now, here again there are different ways of doing it. Now remember, using distance formula, we can find out the distance between 2 points will be x1 minus x2 whole square plus y1 minus y2 whole square, right? And this entire distance square root. So if we know all of these coordinates, right, then I'm talking about right now the triangle ADE, right? So same is true for ABC as well. So the point is, if we know the 3 vertices and their coordinates, applying distance formula, we can find out AD, we can find out DE, we can find out AE, right? So now once we find out the 3 sides of a triangle, we can apply Heron's formula and find out the area of the triangle, right? So if we know the three lengths, so applying Heron's formula, we can actually find out the area of the triangle. There is one other way. The other formula is something that we have learned. So Heron's formula we learned in the last grade, and in this grade, in this class, we learned one more formula. So if we have a triangle whose vertices are x1, y1, x2, y2, x3, y3, then the area of that triangle will be equal to the absolute value of, it will be x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. This entire thing divided by 2, if we take the absolute value of that, that also gives us the area of the triangle. So since this is something that we learned in this grade, we are going to use this formula to find out the area of the triangle ADE. Then we are going to find out the area of the entire big triangle ABC, and then we are going to compare it to find out the relative ratios, right? So let's go ahead, and now that we understand how we are going to solve it, let's go ahead and solve this. So here AD is one part and BD is two parts, because AD by AB is 1:3, correct? So then, so if this is D, so the x coordinate for D will be equal to, it will be 1 multiplied by 1 plus 2 multiplied by 4, 2 multiplied by 4 divided by 1 plus 2, 1 plus 2. So if we do this, this will be 1 plus 8 by 2, which will be 9. Actually, this will be 3 by 3. It will be 9 by 3. That will be 3. 3 ones are 3. 3 threes are 9. So the x coordinate for point D is 3. Now what about the y coordinate for point D? That will be 1 times 5. Let's write it here. It will be 1 times 5 plus 2 times 6. 2 times 6 divided by 1 plus 2. And this should be equal to, we will have 5 plus 6 2s are 12 by 3. 5 plus 12 will be 17 by 3. Kind of interesting number. We didn't get a whole number. We have a ratio, that is fine. So the point D, the coordinates would be, we have 3 comma 17 by 3. This is the coordinates for point D. So similarly, we can find out the x coordinate for point E will be, so let's write it over here. So again, AE is one part and CE is two parts, because AE by AC is 1:3. So 1 times 7, this will be x coordinate will be 1 times 7 plus 2 times 4. 2 times 4 by 1 plus 2, and this should be equal to, so we have 7 plus 8 by 3. 7 plus 8 is 15 by 3, or this will be 5. So the x coordinate is 5. We have to still find out the y coordinate. So the y coordinate, and this is all by as per sections formula, right? So 1 times 2, so 1 times 2 plus 1 times 2 plus 2 times 6. 2 times 6 by 1 plus 2, and we will get 2 plus 12. 6 2s are 12, so 2 plus 12 by 3, or we get 14 by 3. So interesting, we can get another fraction, it's 14 by 3. So we have the two coordinates, or we have the coordinates for the points D and E. So D is 3 comma 17 by 3, and E is 5 comma 14 by 3, right? Now let's give ourselves a little bit more space, and now we are going to calculate the area. So let's write the point coordinates again. So here we have D 3 comma 17 by 3, and E is 5 comma 14 by 3. Now we are going to find out the area for our triangle ADE. Let's find out this. So this will be like we discussed. So this is going to be the absolute value of this number, the formula, right? So we are going to first take A. So the x component 4 times, so 17 by 3 minus 14 by 3. 17 by 3 minus 14 by 3 plus, then we will take the x component for this point 3 times 14 by 3 minus 6 plus we will take the x component here 5, and this will be 6 minus 17 by 3. 17 by 3, and this entire thing is divided by 2. So if we were to actually solve this, so let's do it step by step. So this is for the absolute value, right? So let's make sure that we don't do any calculation mistakes. So both denominators are 3 for the first term, so 3 denominator and 17 minus 3. So this will be 4 multiplied by 17 minus 3 is 3. So 3 by 3, in other words, it will be just 1. This is the first term, right? This is the first term. Then plus the second term is 3 times, so we have denominator as 3 between these two terms, and we will have 14 minus 18, right? Because denominator is 1, 1 3s are 3, 3 6 are 18. So this plus 5 times, denominator is 3 again, and we will have 18 minus 17. 18 minus 17. This entire thing by 2. Let's see if we can actually find out this now. So this will be 1. So here the first term will come down to 4. What about the second term? Well, we have the 3 and 3 will cancel out, and we have minus 4. So 14 minus 18 is minus 4. So we have minus 4. Now plus, so this is 1 by 3. Right? This is 1 by 3, so 5. So this will be 5 by 3. 5 by 3. This entire time, the term by 2, plus 4 minus 4 cancels out. So it will be 5 by 3 times 2, or 5 by 6. So the area for this triangle ADE is 5 by 6 square units. So this is the first part of a question. Find the area of the triangle ADE. So this is 5 by 6 square units. Now let's go back and find out the area for our triangle ABC. Why do we need it? Because we have to compare the two areas, right? We have to compare area of this triangle, right, ABC, with the triangle ADE. So we have found ADE. So area for ADE is 5 by 6. 5 by 6. Now for triangle ABC, we know the coordinates, right? So give ourselves a little bit more space. It is the absolute value of, let's write the term. So the first term is 4 times 5 minus 2. So there should be 5 minus 2 plus, let's take the second term, 1 times 2 minus 6. 2 minus 6 plus the third term, x component is this, times 6 minus 5. 6 minus 5, right? And this entire thing divided by 2. So let's maybe do it over here, give ourselves more space. So the first, so this will be again the absolute value of this. So this will be 5 minus 2 is 3. So 4 3s are 12, right? So this will be 3, 4 3s are 12. Now this is minus 4. 2 minus 6 is minus 4 times 1 is minus 4. and this will be 6 minus 1 is 1, 7 times 1 is 7 plus 7 by 2. Or in other words, this will be, so 7 minus 4 is 3, 12 plus 3 is 15, so this will be 15 by 2 square units. So this is, so the area of the entire triangle, this entire triangle ABC is actually 15 by 2 square units. So how are we going to compare, right? So one is 5 by 6, the other one is 15 by 2. So if you were to compare this, so we will say area of triangle ADE divided by area of triangle ABC will be 5 by 6 divided by 15 by 2, or in other words, this ratio will be 5 times 2 divided by 6 times 15. So 3, 5 ones are 5, 5 threes are 15, 1 by 3 times 3 is 9, or 1 by 9. So now if you would have done the area of triangle ABC divided by area of triangle ADE, you would have got 9 by 1. So both answers are correct. If you take the area of ABC first and divide that by area of triangle ADE, you will get 9 by 1. Or if you take the area of triangle ADE first, divide by area of triangle ABC, it will be 1 by 9. So we have found out the area of the smaller triangle individually, which is 5 by 6 square unit, and the ratio smaller triangle area divided by the bigger triangle area, that ratio is 1 by 9. So I wanted to just also highlight one other thing about, as far as the areas are concerned, the relative areas, right, the ratio is concerned. If very quickly, if you were to think about this as in terms of similar triangles, right, so what is given is that AD by BC, AD by AB is given as, which is same as AE by AC. So, and this ratio is 1 by 3. So using similar triangles, you can actually prove that triangle ADE is similar to triangle ABC. So using similar triangles, we can actually prove, if these two sides are proportional, that these two triangles are similar. If these two triangles are similar, it means that DE by BC is also the same ratio as these, right? So all these ratios are equal to 1 by 3. Now if we were to drop a perpendicular, right, and let's say perpendicular intersects here at X and here at Y. So this is 90 degrees, this is 90 degrees. Then the area for the smaller triangle ADE will be equal to half times AX, right? AX, let's actually give a dot notation here, times DE, and similarly for the bigger triangle it will be half AY, right? AY times BC, or it will be basically the ratio of AX by AY multiplied by DE by BC. Now DE by BC is 1 by 3. So this ratio is 1 by 3. So similarly, if we take a look at this smaller triangle, I'm going to shade this, that is ADX, and the triangle ABY. So we can show these two triangles are similar, ADX and ABY, and from there we can say, because these two triangles are similar, that AX by AY, we can say that, let's write it here, AX by AY will be equal to AD by AB. But AD by AB is equal to 1 by 3, which we know. So this first part will be 1 by 3, and DE by BC is 1 by 3. So this ratio is 1 by 9. I just wanted to give you one other dimension, which is this other perspective, that using similar triangles, we could have gotten the comparison part, meaning without knowing the exact area for triangle ADE and ABC, we can use similar triangles to come up with the second part of the question, that is comparing the area of the smaller triangle to the larger triangle, and that ratio is 1 by 9. So friends, this is how we would solve question number 28.